Well, good morning, afternoon, evening, whatever time it is, wherever you are. Welcome to the MS 500 Exam Cram. As far as what we're going to cover today, we'll first talk through the exam itself, just a few little pointers, and then we'll talk about the various sections in the exam, the specific objective domains, and the skills that relate to the exam. If you don't know who I am, my name's Liam. I'm CEO at Shareclicity, a Microsoft MVP, and also a Microsoft certified trainer. You can reach out to me on my blog site and website, and also on Twitter if needed. Okay, so let's talk about the exam itself. So I suppose the first question you would always want to ask yourself is this exam for me? Well, the MS 500 exam is designed to test your technical knowledge and practice for basically all of the security features and components within Microsoft 365. I'll be honest with you, this is not an easy exam. It's actually probably one of the more complicated exams that I took a while back. The good news is that when you pass the exam, you'll be given the title of Microsoft 365 Certified Security Administrator Associate, because you know they like to have short names for the awards that you get. It is a good exam. It is comprised of specific domains that we'll talk about shortly. And there's also a lab section at the end, which is kind of a bit of a curveball. After you've gone through all the questions and the scenarios, and then they drop a lab on you where you need to go into a virtual machine, into a tenant, and then you complete various tasks. There's about 12 tasks that need to be completed. But as long as you've spent time in the tenant and you kind of know how to do things, you know, for example, creation of an Azure AD application, for example, or configuration of a license against a group, just a few kind of base examples that you might get. Now, of course, it is different each time, but it is a good exam. This one will test you. It's quite extensive. As we go through the domains that we talk about, we may have time to go through some questions for the exam, but based on the sheer amount of domain content that we need to cover, it's going to be more around me kind of presenting things back to you. And then I can talk about specific things in the exam as we go through. So at a high level, the MS 500 exam will measure 4 specific skills, each with several topics that you need to know about. So let's discuss each measured skill broadly, and then we'll dive into each of those areas. So first off, we have implement and manage identity and access. So this skill is 30 to 35% of the exam and includes an understanding and knowing how to set up hybrid security capabilities. More focus here on things like Azure AD Connect and some of the security controls that are around there. The skill covers most of the items that we discussed and were required for the MS 100 exam, for example, which is the Microsoft Identity Services. It builds on top of that exam and then goes a little bit further as it introduces things like privileged identity management and Azure AD identity protection. It also includes conditional access, role-based access, and privileged account and access management. The next domain is implement and manage threat protection. This skill is weighted at 20 to 25% of the exam. In this topic, you'll be measured on implementation of all of the threat management features, including Microsoft Intune, mobile device management, mobile application management, and then also be questioned on Azure threat protection capabilities. And then there's a last little bit around Azure Sentinel use within Microsoft 365. Now, of course, that is a newer piece that was added, but you will need to kind of understand how to at least get data from there into Azure Sentinel. Next, we have implement and manage information protection. Now, this skill is weighted at 15 to 20% of the exam. Now, what's interesting here is that it's a lower amount towards the exam, but the sheer amount of content and things that you'll need to understand, it actually makes it quite strange because it's skilled less, but you'll need to know more. You'll be measured on things like data loss prevention policies, Azure information protection, unified labeling and content protections, and then you'll also be measured on the basic use of cloud app security for protection. And there are a couple of questions around taking on-premises firewall logs, etc., and putting them into cloud app security. And then lastly is managing governance and compliance features in Microsoft 365. This skill focuses on topics such as security reporting and analyzing log data. You'll also be measured on using search and investigation, as well as content search for identifying protection security issues. And then you'll also need to understand the purpose and use of the privacy regulation tooling that is available within the tenant. So now we have a sense of the high level of the skills and topics you'll need to know to be successful in passing the exam. We'll take a look at each of the skills in more detail and run through some basic information that you'll need to know. And we'll start with implement and manage identity access. Now, the way this will flow is we'll kind of talk through topics very quickly. Now, for example, each one of these sections, for example, if you wanted to follow on and do the MS 500 course, each of these sections are a course in their own right, and they have upwards of 6 or 7 modules within each course. So I'm going to try and condense as much information as I can to give you what I think are the most important pieces that you'll get questioned on. So the first thing to talk about is the Microsoft 365 hybrid cloud components, and to understand that there are 3 core areas that are included in this hybrid cloud component infrastructure. The first one is software as a service. This one will include Microsoft Office 365, Intune, and CRM. And your core scenario here is that you want to combine these services with on-premises services or applications. The next 2, you're not going to get questioned on too much, but they are important to understand, which is Azure Platform as a Service, or PaaS. This is about creating cloud-based applications. So, for example, you want to combine PaaS services or an application that you've built within the Azure architecture with on-premises resources or applications. And then you have Azure IaaS, or Infrastructure as a Service. This is all the most common utilization of the cloud, which is really around virtual machines that are connected to your on-premises network. Now, of course, when we start to plan a hybrid cloud, there are 4 key areas that need to be addressed. The first one is networking, then identity, and then security, and then management. Networking for hybrid cloud scenarios includes the connectivity to the Microsoft Cloud platforms and services, and also the bandwidth that needs to be available during peak loads. From an identity perspective, these are the scenarios around Azure AD being the common identity provider, or synchronization from on-premises using Active Directory domain services and Azure AD Connect, or federation such as using ADFS. And ADFS is brought up a couple of times in the exam as well. From a security perspective, we're talking about protection and management of the identities, data protection, admin privilege management, threat awareness, and the implementation of governance and security policies. And then, of course, from a management side, it's all about maintaining the settings, the data, accounts, policies, and permissions, and being able to either utilize PowerShell. There are a few questions on PowerShell commandlets that you might want to utilize for management, but most of it is targeted to the actual admin centers themselves. And then, of course, it also does talk about using things like System Center for management, as well as being able to manage virtual machines. Okay, so the typical path that you would choose to go from on-premises network to the cloud is really based around this kind of idea. So you have your on-premises network, which is the edge that will connect to the internet through a WAN link to your ISP. The traffic will then travel through the internet to the edge of the Microsoft Cloud. The cloud offerings within the Microsoft Cloud, obviously, you've got Office 365, Microsoft Intune, Microsoft Azure, Dynamics 365, etc. Users of the organization can be located basically in either of those. They can either be on-premises accounts or they can be in the cloud. But either way, the traffic will route directly through those. Now, if we're not using express route connection, the only part of the traffic path to the Microsoft Cloud that you can control, or at least have some element of control over, is the on-premises link through the ISP to the edge of the Microsoft Cloud. The path between your ISP and the Microsoft Cloud edge is a best effort delivery system based on just regular internet, and we all know how that goes. The second option that's available to us here is the express route. Now, traffic to utilize express route can go a few different ways depending on the type of traffic that's moving backwards and forwards. So, for example, traffic to Microsoft Intune can travel the same path as normal internet. Traffic to Office 365, Microsoft Azure, and Dynamic 365 can travel across the Express route connection, which is a dedicated path between the edge of the on-premises network and the edge of the Microsoft cloud. Now, when you utilize an Express route connection, you have control through a relationship with the ISP provider that has a relationship with Microsoft also, and you have control over the entire path from one end to the other. You can now count on predictable throughput and, of course, latency based on the service provider's connection to the Microsoft cloud. And then traffic sent over the Express connection is no longer subject to internet outages, traffic congestion, and monitoring. So from a recommendation perspective and an exam perspective, Express route is a common architecture design that you should then look at utilizing when trying to connect an on-premises network directly to the Microsoft cloud. Now, of course, as part of this process, that's just the connection. Our next kind of piece as part of this is understanding the synchronization technologies that are available to us as far as accounts on premises and moving them to the cloud. Now, the most common technologies, or topologies I should say, are single forest, single Azure AD tenant. This is the most common topology. It's a single on-prem forest with one or maybe multiple domains and a single Azure AD tenant. In all fairness, most environments I've ever looked at are modeled after that idea. There's also support for multiple forests with single Azure AD tenant. This is a second most common, where the idea is you have multiple forests which contain multiple domains. You don't have to join the server that's connecting to the domain. If necessary, to reach all the forests, you can place the server in a perimeter edge, for example, like the DMZ, and kind of push out to the Azure AD tenant. But it effectively will allow you to feed accounts from multiple forests. We then also have multiple forest single sync server and users represented in one directory. So this is all the on-premises forests are treated as separate entities. No user is present in any other forest, and each forest has its own exchange organization, and we're not doing a GEL sync between the forests. You've then got multiple forests that match users. So this is common to all the scenarios. For doing distribution and security groups that can contain a mix of users, whether they're contacts or what's called FSPs or foreign security principals. FSPs are used in Active Directory to represent members from other forests in a security group. So we can take all of the multiple forests and kind of match them all together and then sync those out. You also have multiple forests full mesh with optional GAL sync, so kind of like the previous one, but you're going to synchronize the global address list, and that's commonly implemented through things like MIM 2010 or, well, sorry, FIM 2010 or MIM 2016 now. Azure AD Connect can't be used for the on-premises GAL sync. And then your last one here is multiple forests, which is called an account resource forest. So in an account resource forest topology, you have one or more account forests with active users, and you also have one or more resource forests that have effectively what are referred to as shadow or disabled accounts. In this scenario, one or more resource forests trusts all the account forests. The resource forest typically has an extended AD schema for Exchange and Skype and things like that. And users have a disabled account in that forest, and the mailbox is linked to the other one. And then we sync together. So even though there's a few different options here, from an exam perspective, you'll only get questioned normally on the first two, definitely on the first one, so single forest. So when we have a single forest with Azure AD Connect, this is the most common topology with one or more multiple domains. For Azure AD authentication, utilizing password hash synchronization is also the most common. For most environments, this is what you will see. Azure AD connected to Active Directory on-prem, synchronizing the password hash, so that then there's the single sign-on. And then this is called the express installation of Azure AD Connect. And the topology kind of works very similar to this. So there's an on-premises Active Directory, which is then connected to an Azure AD Connect sync server. In most instances, that's actually the same server as Active Directory, but best practice is not that. And then this is then connected to Azure Active Directory. So the most common design is this for most environments. Now, of course, our second most common is the multiple forest with single Azure AD tenant. So this is for environments with multiple on-premises AD forests. So there are multiple reasons for having more than one on-premises. Typical examples could be account resource forests, or maybe a merger or an acquisition. When you have multiple forests, all the forests must be reachable by a single Azure AD Connect sync server. That server doesn't have to be on the domain, but it does need to be able to get to all of those other servers. Now, the Azure AD Connect installation wizard will offer several options to consolidate users who are represented in the multiple forests. So the goal is that a user is represented only once in Azure AD. So there are some common topologies you can configure in the custom installation that will kind of allow you to do that. There is a section called uniquely identifying your users where you're able to define what that would look like. So from an architecture perspective, we have our on-premises Active Directories. We then have our Azure AD Connect sync server that can see both of those, which will then sync to Azure Active Directory. Okay, so how does the Azure Active Directory Connect process actually work? Well, this is how the architecture is defined. So what we have on the one side, so imagine you've got a left and a right side of the application. You have what's called the connected directory, so the CD. This is the Active Directory forest, and that's what it connects to. On the other side of this, we have the other connected directory, which is the Azure Active Directory. So there's two CDs, one on each side, and then in between this, we have the Azure AD Connect provisioning engine that kind of ties these two together. Now, inside of this, there is a SQL database, and then we've broken down into three core blocks. One is called a connector space, then there's what's called the metaverse, and then there's a second connector space. So this is how Azure AD Connect actually works. So we connect from the one side, and then this will do an import of the accounts or security groups into the connector space. Then from the second side, it can also export information from one side to another if we define that. In between all of those is a sync process that runs inside the engine itself. And then, of course, we have the export from the second connector space to Azure Active Directory, and then we also have the import. So the process is threefold. We have the import process. So step one of the synchronization process will update from the connected data source to its connector. The synchronization process, there's an inbound and an outbound synchronization, and the metaverse in the middle is all about communication and mapping of specific properties. So when you actually look under the covers, it's mapping, for example, the Active Directory mail property to the Azure AD mail property. And the metaverse kind of ties that together. And then, of course, step three of that, which is the export, is it takes what it's bought in from AD on-prem, mapped it to the metaverse, and then exports it out directly into there. Now, it's important to understand that you may hit synchronization performance issues. The key ones for this are really around the number of objects that you wish to import. So if you're importing from a large Active Directory or a large directory structure, then you can have some performance issues. Also, hardware and software requirements for Azure AD Connect. So make sure that the Azure AD Connect server meets at least the minimum, if not more, and also has the best connectivity it needs. Network latency and slowness obviously can cause a problem here as well. Obviously, that's self-explanatory because you're going across the internet. Then, of course, you've got Azure AD throttling. So Azure AD has a throttling limit of 7,000 writes per 5 minutes, so about 84,000 per hour. So, for example, if you were using Azure AD Connect, export into Azure AD, and you had some PowerShell scripts in the background that were doing stuff, for example, dynamic group memberships, or you were updating records, that plays a role in Azure AD throttling. So it's always important to make sure that you don't have too many automated processes that are running against Azure AD when you're trying to utilize the Azure AD Connect. And then, of course, the overall size of the Active Directory. So, for example, if you have a very large Active Directory, so, for example, 100,000 users, then this can reduce the actual performance itself because it's trying to write those values into that SQL kind of database, and then that becomes a performance problem. You can also obviously have issues with drives. So if you're using slower disk, instead of using solid state drives for the SQL side of it. For example, if not, you could also use RAID 0 or RAID 1 configuration. And then, of course, just really figuring out how often you want this to be synchronized, whether it's going to be constantly, or maybe you don't do a full sync. Maybe you just do a sync as is needed. So just some things to be aware of, that there are some performance impacts that can happen when utilizing Azure AD Connect. Okay, so let's talk about the authentication then. So after we have our directory architecture, we have our Azure AD Connect synchronized, the next step is obviously to understand the authentication process. So how do we choose an authentication mechanism? Well, the decision that comes is really based around when you move to the cloud. So the first business goal in authentication is, are we going to allow people to sign into the cloud? The authentication method is a critical component of an organization's presence in the cloud. And then, of course, we need to look at how we control access to all of the cloud data and resources. And it's actually the foundation of all other advanced security and user experience features in Azure AD. And the authentication method is difficult to change after it's implemented. So for you, it's to identify, is the new control plane for IT security. So authentication is the organization's access guard to everything in the cloud. So you as an organization will need to identify the control plane that strengthens your security and then keeps the cloud apps safe from intruders. So how do we decide which one to go with and what's available? Well, let's walk through the authentication decision tree. So first off, Azure AD can handle the sign-in for users without relying on premises components to verify the password itself. So you can see as it starts to flow out. So for example, if we handle Azure AD sign-in completely in the cloud, then our next decision outside of that is to enforce user-level Active Directory security policies. And you can see as we flow backwards and forwards, it'll keep loading. That depending on what we choose, we basically end up with these 5 options at the bottom. So we're either going to end up with password hash sync and seamless SSO, which is the most common. So that means Azure AD Connect is connected and the password is synchronized, well, the hash is at least, so that when I change my password on-prem, then I'm able to log into Office 365. We also then have a second option, which is pass-through authentication and seamless SSO. So what this one's going to do is pass us out from on-prem straight through to there for a seamless type of login. We've then got pass-through auth and seamless SSO with password hash. So the difference between the two there is that the first one isn't providing password hash. It's just passing through single sign-on, and you will get prompted at some point, but you can do password hash. The next option there, which is federation, we're talking about ADFS there. So we're utilizing an on-premises ADFS implementation. And then, of course, federation with password hash sync is when we enable the password reset capabilities in the cloud. So we can change the password in both ways. So from a password hash synchronization perspective, it's either one way from on-prem to the cloud, or we can do two-way and then allow that password to be synchronized between the two. So what are our deployment scenarios then when we're looking at the authentication? Well, if we look at the services that are available to us, there's 8 of them. So the first one is multi-factor authentication. Azure multi-factor authentication is that 2-step verification. So using admin-approved authentication methods, MFA obviously can protect the data and the applications and streamline who can log in and at least ask an end user to provide a second factor of authentication. And next in the list is conditional access. So this is where we implement automated access control, whether it's based on specific properties of, for example, a device, or whether it's risky or user sign-in enumeration to be able to say, well, this is a risky login. Then, of course, we have self-service password reset, where your end users can reset their passwords without you as the administrator having to intervene. Privileged entity management helps you manage the privileged admin roles across Azure AD, as well as other Azure resources and Microsoft Online Services. So PIM, as it's referred to, is all about just-in-time access and approval workflows and fully integrated access review, so you can identify and cover and prevent kind of malicious activities against privileged roles and accounts. Of course, we've got single sign-on. So single sign-on to other applications, whether we're using SAML authentication, for example, Office 365 to Salesforce or Dropbox or Box or some other mechanism. So after you've enabled single sign-on, users won't need to type their passwords in to sign into Azure AD. They can type their names instead, and then they'll be able to get through utilizing multi-factor or one-time passwords or whatever it would be that you've chosen. For federated services, with password hash synchronization, obviously the passwords are synchronized to the cloud, and then this will allow the end user to go to the federated services platform. Let's say it's on-premises ADFS. They can have cached credentials posted to federated services, which can be used to protect on-premises applications, as well as allowing them to connect directly into Office 365 with the same authentication token. We then have an application proxy. If you do want to protect on-premises applications, maybe you have an on-premises SharePoint implementation, you can then build an application proxy in Azure, which will then utilize Azure Authentication and protect that together so that you're able to protect both with the same authentication mechanism. And then, of course, Azure AD helps you to automate the creation, maintenance, and removal of user identities, for example, in cloud security, in cloud applications such as Dropbox, Salesforce, as well as inside itself. Now, once we've defined the types of authentication that we wish to support, in all fairness, most people will take the on-prem Azure AD Connect single sign-on experience, potentially with password hash, to Azure AD so that it becomes a seamless process. The next thing is to understand Azure AD membership types and what's available to us. There are 3 core types of memberships. The first one is an assigned. So this is I'm going to refer to this as the old school way of doing something where, for example, you're on-prem in Active Directory and you want to add someone to a security group, you assign them to that group. Now, in Azure AD, we have 2 dynamic capabilities that are available. This is based on licensing too. So, for example, you can use dynamic membership rules to automatically add and remove members. So if a member's attribute changes, for example, Office 365 or Azure AD at least will then either keep them in or remove them out based on those properties. There's also a dynamic device. So if you're adding devices into groups, we can obviously interrogate the device when it accesses Office 365 at the Azure AD level and at the Intune level, and then we can determine whether that should be added or removed from those specific memberships. Now, when you're assigning licensing, which will also come up as a question at some point on the exam as well, the best way is to utilize security groups, and often a cleaner way is to use dynamic user groups to be able to do that as well. Now, you can create a dynamic group for either devices or users, but you can't put them both in the same one. You also cannot create a device group based on the device owner attributes. So device membership rules only reference device attributions. So just be aware you can't say I'm going to put Liam in there and then Liam's iPhone. It doesn't quite work that way. You obviously have to utilize the reference of the device and say, well, that was Liam's iPhone. I want to add that into this specific groups. Now, in order for you to use those dynamic groups, there are some specific requirements. The first one is a license one. You will need Azure AD Premium P1 license for each unique user that is a member of one or more dynamic groups. This will be questioned on the exam as well. You don't have to assign licenses to users for them to be members of a dynamic group, but you must have the minimum number of licenses in the tenant to cover that. So if you have 1,000 unique users in all of the dynamic groups in the tenant, you would require at least 1,000 licenses for Azure AD Premium 1. Even though they may not be assigned to those users, as long as you have them, then you're okay to add those users in there. Now, of course, if we were going to be utilizing Azure AD dynamic groups, we can obviously utilize complex attribute-based rules to enable those memberships. So, for example, if we have user 1 and user 2, and our query here is, does the department equal sales? Then, of course, based on whether they pass that query, would determine whether they're added or removed. The second option, if we're using device properties, so let's imagine we're using tablets and phones, is the device operating system Android for work? Same principle applies. If it is, then it's added. If it's not, then it's removed or it's not added. We can use dynamic group rules syntax. It's really based on 3 key properties. So a membership rule can obviously uses a binary expression. So it's using the property, an operator, and then a value. So for example, it can be account enabled equals true or false, or it could be company name starts with, and then I'm using micro for Microsoft, or it could be the state is in one of these values. So we're able to create these dynamic group rules to process users or devices and add those in. Now, of course, when you're going through the exam, there are dynamic group questions about how to add specific users. As a side note here, most of the questions that you'll get are all based on scenarios. If you haven't taken the exam yet, then just be aware there's extensive scenarios for each batch of questions, and the scenarios will have all of the information that is expected to be met when you go through the questions. So for example, a question could be something of, well, you have these many users and these are the security requirements, and you need to make sure that all of these type of people are inside a dynamic group. What would the rule? And then there's some syntax options that you can select from. Okay, so now that we have our authentication method chosen, we have our security groups. Our next thing is about the protections that are available, for example, when end users sign on. So there are a few common ones that are available and are ones that are covered as part of the exam. So multi-factor. So Azure multi-factor will obviously help protect at the front door when an end user tries to come in. We then have passwordless. So this is using the Microsoft Authenticator app. So this does require that you have the app on a device of some description and you have a pin on it or fingerprint or your face. And the idea being here that when they access it, it prompts them and says, are you sure you want to let them in? And you say yes, and off they go. There's also risk monitoring. So the risk monitoring that is provided, it gives recommendations to improve overall security posture. So for example, it'll calculate sign-in risk levels, user risk levels. It'll send notifications for risk events. Obviously, you can perform investigation, and then it will provide a basic workflow to track those types of investigations. Now, the big one here is conditional access. This is one of the big boys, and this is where you can create policies to mitigate risky sign-ins by either blocking those sign-ins or requiring multi-factor authentication. You can also block or secure risky user accounts, and you can also force users to register for multi-factor authentication. Now, of course, if we look at the different sign-in experiences, if we're utilizing multi-factor authentication, then we can obviously force end users to register for multi-factor authentication. And then from that point forward, they will then have to go through and complete that multi-factor process every time. The second one is what we call the sign-in at risk. So risky sign-in, obviously it has sign-in recovery, sign-in blocked, or a forced multi-factor registration during that risky sign-in process. Now, the user at risk mechanism is really looking for compromised accounts, recovery, and account blocking. So the response of the system to these kind of issues will have an impact on the sign experience that the end user will actually have. So when you're looking at implementing the best sign experience, you might need to be aware that there are multiple different outcomes here, and that based on whichever one of these it matches will dictate what the end user actually has to do. So for example, if you've enforced multi-factor at the user level, but then you've also done a sign-in risk policy that will enforce multi-factor, just be aware that depending on how it identifies this at the point of authentication, it could then force double multi-factor authentication processes, depending on how that gets recognized in the system. Now, before starting a deployment of multi-factor authentication, there are some core prerequisites that need to be kind of completed. So cloud-only identity environments with modern authentication, if you're utilizing that as the scenario, then there are no additional prerequisite tasks whatsoever. If you're utilizing hybrid identity, then you'll need to have Azure AD Connect deployed and then synchronized the identities into Azure Active Directory. If you are utilizing on-premises legacy applications that have been published to the cloud, then you'll need to make sure that Azure AD Application Proxy is deployed as well. If you're using Azure Multifactor with Radius, then you'll need to make sure that you have a network policy server that's been deployed. Now, there are some deployment considerations here. So one of these, it's critical to inform the users, communicate to them about the upcoming changes and what the requirements would be. There are two things here that are available to you. One is the multi-factor templates. You can go and download those. That's not a security thing. That's just email templates that you can then use to send emails to end users. And then, of course, you've also got end user documentation that's available to help them understand what that means. Azure multi-factor authentication is deployed and should be deployed by enforcing policies with conditional access. Even though that you can do that with individual users and assign it, the best practice is now conditional access policy. A conditional access policy can require users to perform multi-factor authentication when specific criteria is met. A conditional access policy obviously can require multi-factor to be forced. And this could be done when it meets, for example, any of these specific criteria. So it's a specific user or member of a group or assigned role, a specific cloud application. So for example, maybe you've got it when somebody tries to access the SharePoint app, or maybe it's Microsoft Teams, the device platform, it's Windows 10 or it's iOS, the state of the device, is it a risky device? Network locations, is it coming in from a country other than where you would expect it? What the client application is that's making the connection, the sign-in risk if you have identity protection enabled, whether the device is compliant, that's down to the device being registered and then having a compliance value associated to it, whether it's hybrid Azure AD joined or not. So if it's, for example, a Windows 10 device that's connected to your on-premises AD and then also connected to Azure AD and registered. And then, of course, if it comes from an approved client application. Now, there are three core device identity options that you can utilize to help in protecting and choosing whether to enforce multi-factor. So the first one is Azure AD registered, Azure AD joined, and then hybrid Azure AD joined. The goal of the Azure AD registered device is to provide you with the support for bring your own device. In this scenario, a user can then access organizational applications that are protected via Azure AD using a personal device. Azure AD registered or joined is really for Windows deployments of work-owned devices, or it allows access to organizational applications and resources from a Windows device that's been joined to the Azure AD. For example, I have an Azure AD tenant, but I don't have an on-premises domain, but my laptop, for example, is Azure AD joined. So instead of it being registered as just a device, it's fully joined and managed inside Azure AD. So this means I can perform cloud-based management of the device, and the users to sign to their devices, they can use their work or school accounts to be able to get in. And then, of course, the hybrid Azure AD. So if I was to have an on-premises AD footprint and I wanted the benefits of both, then I could join it to both of those, and then I could then use that inside a conditional access policy and say, is the device hybrid Azure AD joined? So is it on-prem and cloud? And then I could do something with that. Now, to actually perform the Azure AD device registration, we have our device and we have SharePoint Online. So the user tries to connect to SharePoint Online. That's the first request, let's say, that goes from my device. The authentication request is then sent back. And then at this point, the user is redirected to the Azure AD login. Now, if I already happen to have an Azure AD authentication token, there's no login that's processed here. It's just cached and I'm done because I have an authentication token. The user authenticates, so let's say it's me, I've authenticated, my device then gets registered, and then I'm granted access to that application. And this is the flow that every device will go through from a registration perspective. This isn't Azure AD joined. This is just what every device will go through. And you will see these listed inside Azure AD under devices. And also you can see them in Intune as well if you have the licenses for that. Now, of course, if you want to do the Azure AD joined, we have the corporate device, we have SharePoint, we repeat the same process. So we try to access SharePoint Online. The authentication process is then sent, and a domain join requirement is then issued. The corporate device is then authenticated and then joined. You'll see it goes backwards and forwards between Azure AD, and then application is then granted. They can register the devices directly to Azure AD. Okay. Now, if we're doing hybrid Azure AD joined, the hybrid is a feature in Azure AD that lets you use both the on-prem and the Azure AD at exactly the same time. So if I have a corporate device that's joined to Azure Active Directory, and then, of course, Active Directory AD Connect is then connected, it will then synchronize from there to Azure AD. So the Azure AD Connect is the piece that will be connecting that together. So as long as the domain is registered in the corporate device for on-prem and Azure AD Connect is synchronizing, it will then add the device to Azure AD as well if you enable that option. Okay, so obviously we talked about a few bits and pieces, so authentication methods, and then obviously groups, and then kind of connecting things to the domain. So our next thing is conditional access policies and device policies that kind of control that. So what are conditional access policies? So conditional access policies are a way of controlling how users and devices will connect directly into the specific locations. So whether it's on-prem, whether it's cloud, or whatever it would be. So for example, let's say we have some devices, we have a user, we have our on-premises apps, and then we have cloud apps, and then we also have a block access component too. So in this instance, it's going to be validating, is the user a member of a specific group? Is the cloud application available? What's the device state? Also the location, the client application, and then of course the sign-in risk. Based on these properties, it will then either grant access to the on-premises app, the cloud apps, or block access. Now, conditional access policies are a core component that's brought up multiple times inside the scenarios in the exam, based around, this is an organization that has so many people and they want to control, XYZ type thing. And the answer is a conditional access policy. A conditional access policy is a definition of an access scenario that uses this kind of pattern. So when this happens, it defines the reason for triggering the policy. The reason is characterized by a group of conditions that have been satisfied. In Azure AD conditional access, the two assignment conditions are the user, so the who, and then the cloud app, the what. So these two conditions are mandatory in a conditional access policy. In addition to those two conditions, you can also include additional conditions that describe how the access attempt is performed. So with Azure AD conditional access, you control how the authorized user can access the cloud apps. And then, of course, we have an outcome here, which is then do this. Now, there are some core requirements here for licensing. You do need to have Azure AD Premium P1 license. That is included in other licenses. But if you're using it with identity protection and you want to utilize and query that as part of it, then you need to have the Azure AD Premium P2 license. Now, of course, these are included in the Microsoft 365 licenses, not the Office 365 licenses, but the Microsoft 365. The two differences there, an Office 365 license does not include Windows 10. A Microsoft 365 license does. Then, of course, we have Enterprise Mobility and Security, E3 licenses and higher. And that's where you'll get the Azure AD Premium licenses bundled together with Cloud App Security, as well as things such as Intune and a few other bits and pieces. So you will need to have the right licenses available in order to utilize conditional access. So some examples here: if you're planning policies, you need to define the when and the what. So for example, the when would be an access attempt is made. So Cloud App by users and groups from outside the corporate network on an untrusted device platform. So that's the requirement here. What do you want to do? I want to block access to the application. Another scenario would be the Cloud App is accessed by users and groups from outside the corporate network. Again, this time you want to grant access with requiring multi-factor authentication and requiring a device compliant. And that's an and, so it requires both of those. Then, of course, we have the same attempt made again, and then we're going to utilize an or. So when you're looking at the scenarios with questions that will be based around conditional access, these are the types of things you need to look for. So a user's attempt to access this, I wish to do something, what configuration would you have in a conditional access policy? It's important to understand actually the naming convention. This is one more of a suggestion of something that makes more sense. So the components of a conditional access policy are really a sequence number, the Cloud App it applies to, the response that you want to happen, and then who it applies to and when it applies. So if you throw all these together, you can basically build and form a name convention for building conditional access policies. So for example, the ID of my policy, I'm going to call it SPO01. The app name that I'm going to be connecting to and protecting is SharePoint. The response is I want to enforce or require something. And then you've got the for option, which is going to be joining. So for the sales, which is the security group, and when it meets a specific condition of outside. So what I end up with is a naming convention that's called SPO01-SharePoint require MFA for sales when on external networks. So it means that when you go to your list of conditional access policies, you have a nice naming convention of things that are there. Now, this is just one that is in there that I thought was helpful. You won't necessarily see them in the exam named this way, but this is one that's helpful. Now, of course, we can utilize device compliance policies too. We can utilize Intune, Azure AD, and conditional access policies. So Intune uses Azure AD conditional access policies to help enforce compliance. So when a device enrolls in Intune, the Azure AD registration process begins and the device information is updated in Azure AD. One key piece of information is the device compliance status. This compliance status is used by conditional access policies to block or allow access to email and any of the other applications that you've restricted. Now, of course, we can utilize this with conditional access or without conditional access. So for devices that comply to policy rules, you can give the devices access to the applications that you need. If the devices don't comply to the policy rules, then they don't get access. Now, you can also use device compliance policies without conditional access. So a compliance policy is different and independent from a conditional access one, and this will target devices and then evaluate the devices and utilize the reported compliance status. So you don't always have to use a conditional access policy. You can get away with using a device compliance policy, which is available in Intune. Now, the prerequisites for utilizing this is you need to have Intune or Azure AD premium subscriptions, and it also needs to be a supported platform, as well as enrolling the devices into Microsoft Intune. This will give you the compliance status. So that's one critical piece here. You need to have the devices enrolled in Intune to be able to query and utilize a compliance status. And then you can enroll devices to one user or no user. So you have the flexibility. You can just enroll a batch of devices and then assign them to users later or to nobody. It's entirely up to you. Okay, so once we have our policies, our next step here is to focus on the role-based access that we wish to define. So the first thing to question here is, what is role-based access control, or RBAC? So in Microsoft 365, this is about granular user and group control. It's about granting users with the least privilege access control. It's about segregation within teams and users, and I should also add in applications also. It ensures that users cannot access sensitive information and ensure users cannot perform high-level tasks. Now, of course, from an assignment perspective, so let's look at an example. So in this example, we have our security principal, which is the sales security group, which is then assigned to the contributor role for the sales resource group. This means that the users in the sales security group can create or manage Azure resources in the sales resource group. Sales users that do not have access to resources outside the sales resource group won't be able to do anything. So role assignment is a little bit bigger than Office 365. So when you look into the role-based access control capabilities, they do span into Azure capabilities. But of course, that's good because Microsoft 365 as a service is a little bit more than just SharePoint Online, OneDrive, and Exchange. It encompasses some of those Azure services, which is why you see virtual machine contributor, backup operator, virtual machines, etc. Now, there are some specific role-based access groups that are available. The first one is owner. This gives you full access to all resources, and you can delegate access to others. So, for example, these are the service administrator and the co-administrator roles are actually assigned to the owner role at the subscription scope, and it applies to all resource types. You've then got a contributor who can create and manage all types of Azure resources, but cannot grant access to anybody else. You've then got the reader who can view Azure resources, and it applies to all resource types. And then, of course, you have your user access administrator, which can manage user access to the Azure resources. Now, you might wonder why we're talking about Azure resources versus Microsoft 365, and that's because they effectively are one in the same. Azure Active Directory is governed by RBAC 2, which would be an Azure resource. So at a high level, Azure RBAC roles control permissions to manage Azure resources, while Azure AD administrator roles control permissions to manage Azure Active Directory resources. Now, if we just do a comparison between the two, if we look at the Azure RBAC role, we've got manage access to Azure resources, and then we've also got the Azure AD administrator roles can manage access to the AD roles. In the RBAC roles, we can support custom roles. In Azure AD, we cannot create custom roles. In RBAC, the scope can be specified at multiple levels within Azure and Microsoft 365. Azure AD admin roles are actually scoped at the tenant level. And then from the RBAC one, the role information can be accessed in the Azure portal, Azure CLI, PowerShell, Resource Manager templates, and the REST API. Role information can be accessed for Azure AD in the admin portal, the Microsoft Admin Center, Microsoft Graph, and Azure AD PowerShell. And the reason I kind of touch on this is when we talk about privileged identity management, privileged identity management process can see all of these roles, whether they're Azure AD ones or whether they're RBAC roles and groups from Azure. Okay, so let's move on to how we protect and manage identities now. So privileged identity management helps you as the IT or the organization to manage the who, the what, the when, the where, and the why for the resources in the organization. It'll provide just-in-time privileged access to Azure AD as well as Azure resources. You can assign time-bound access to resources using start and end dates. You can require approval to activate the privilege roles. You can enforce multi-factor authentication to activate any role. You can also use justification to understand why users activate. You can also get notifications when privilege roles are activated, and you can also conduct access reviews to ensure that users still need those roles. You can also then download the audit history for internal or an external audit. Now, to utilize privileged identity management, the directory must have a valid license. So the prerequisites to utilize this are either a paid or a trial license of Azure AD Premium P2 or the Enterprise Mobility and Security EMS E5, the additive license, or the Microsoft 365 E5 license, it should say, not M, sorry. So we have 3 licenses that are available. Now, of course, there are different capabilities that are available depending on the license that you have also. So from an identity protection perspective, we have the free one. So Azure Active Directory free and basic editions, and you may wonder what that is. That's actually what you get when you provision a Microsoft 365 tenant. You get a Azure Active Directory free / basic edition. And in there, you get a list of risky sign-ins. So you can go into Azure AD and click on risky sign-ins, and it will list those for you. If you then have Azure AD Premium 1, this allows you to examine some of the underlying risk events that have been detected. So you can drill further into those risky events that have taken place, and you get access to some of the reporting. If you then have Azure AD Premium 2, you get all of it, most of the detailed information about all of the risks, configuration of security policies that can automatically respond to those risk levels. And they're broken down into what's called risky user and risky sign-in. So what is a user risk? A user risk represents the probability that a given identity is potentially compromised. The user risk is calculated by considering all the risks associated. So all the risky sign-ins, risk events that were not linked, the current user risk, and then any remediation or dismissal actions performed up to date. Now, of course, when we see those, one of the outcomes of this is to perform, for example, an access review. So it's a good idea to check how many users have administrative access, how many of them are global administrators, and if there are any invited guests or partners that have not been removed after being assigned to an administrative task. You can create a review on a group to ensure those who still need access should have continued access. Asking a group member or owner to review the group membership prior to the group being used will help mitigate some of those people kind of staying in when they shouldn't. Also, asking people outside of IT to sign off and give justification on why they need access for auditing purposes, so you have a trail. As an IT admin, you can manage the task, you avoid oversight of policy exceptions, and provide auditors with proof that these exceptions are reviewed regularly. Employee access might be automated with some, on-prem IAM, but not invited guests. If a group gives guest access to business sensitive content, then it's the group owner's responsibility to confirm the guests have legitimate business need for access. And then recurring access reviews of users at set frequencies, such as weekly, monthly, quarterly, annually, and the reviewers will be notified of each review. Okay, so now let's move on to our next skill. Our next skill here is implement and manage threat protection. So Azure Advanced Threat Protection is a cloud-based security solution that leverages Active Directory signals to identify, detect, and investigate advanced threats, compromised identities, malicious insider actions directed at the organization. It's broken down into a key set of components and features. The first one is it helps you monitor users' entity behavior and activities with learning-based analytics. Also protect user identities and credentials stored in Active Directory. Identify and investigate suspicious user activities, and then look through the entire lifespan of the kill chain. And then, of course, provide clear incident information on simple timelines to be able to triage those issues. Now, Azure ATP provides some of this capability. So the Azure ATP portal allows creation of ATP instances, and it displays the data received from the sensors and enables you to monitor, manage, and investigate threats in the environment. Now, the Azure ATP sensor is installed directly on the domain controllers. The sensor directly monitors domain controller traffic without the need for dedicated server or configuration or port mirroring. Now, the reason that's brought up is historically the older on-prem versions used to use a port mirroring process to be able to capture what was going on. And then, of course, we have Azure ATP Cloud Service that runs on Azure infrastructure and is currently deployed around the world. The Azure ATP Cloud Service is connected to Microsoft's Intelligent Security Graph. From an architecture perspective, a sensor is installed directly on the domain controllers. The Azure ATP sensor then accesses event logs it requires directly from the domain controller. After the logs and network traffic are then passed by the sensor, the Azure ATP sends that information to the logs so that we can then review and capture that. We can also get email and notifications from that architecture also. So in the ATP portal, we can create the instance, we can integrate with other Microsoft security services. You can also manage the sensor configuration settings, view the data that's come back from the sensors, and then of course you can monitor suspicious activities and attacks. Now the sensor itself is in charge of capturing and inspecting the domain controller traffic, receive Windows events from the domain controllers, also receive radius accounting information if you're using a VPN provider, and also retrieve data about users and computers from Active Directory domain. It can also perform resolution of network entities, so it can understand users, groups, and computers, and then transfer the relevant data to the cloud service itself. Now, there are some prerequisites here to be able to utilize this. The first thing, as always, is to be licensed. So you need to be licensed for Azure ATP. So Enterprise Mobility Security E5, so the EMS E5 license, or licenses from a cloud solution provider that include this capability, or you can get the standalone Azure ATP license. The account that you utilize needs to be a global administrator or security admin in the tenant. You also need to verify the on-premises domain controller has direct internet access. The on-premises AD user account and password needs to have read access to all the objects in the domain. And then the account should have read-only permissions to the deleted objects container, so at least it can see what's been removed. Access to the Azure ATP portal is done via the browser, so use the most up-to-date version of your browser of choice, whether it's Edge, Internet Explorer, Google Chrome, etc. And then make sure that you have obviously correct access via the internet. You may end up finding, if you have a proxy or something else, that you may need to open star.atp.azure.com over SSL so that then anybody can get to that. Okay, so once we've figured out ATP to be licensed and enabled, our next thing is to look at the next version of ATP, which is going to be covered in what's called Defender ATP. So Microsoft Defender ATP provides specific capabilities. The first one is threat and vulnerability management. It's a built-in capability that will use risk-based approach to discovery, prioritization, and remediation of endpoint vulnerabilities and misconfigurations. It also provides attack surface reduction by ensuring configuration settings are properly set, and then mitigation techniques are applied for things like malicious attackers and exploits. Then, of course, we have next generation protection. I always love that phrase, but basically it's utilizing modern technology to be able to identify emerging threats that are available. Also, endpoint detection and response capabilities are put in place to detect, investigate, and respond to those advanced threats. Also, it provides automated investigation and remediation. So Microsoft Defender ATP will obviously be able to identify something, notify, and then perform a remediation if that's how it's been configured. And then it also includes something that you may have seen before called the Secure Score. It helps you dynamically assess the security state of the enterprise. It's a great tool in the admin center that you can see, even if you don't have Defender ATP, you can utilize Secure Score to help you at least identify specific things that need to be changed. In order to utilize it, Microsoft Defender ATP requires one of the following licenses, and these are the more expensive licenses, obviously, Windows 10 Enterprise E5 or Education E5, and then the Microsoft 365 E5 and E3, which will include those capabilities. And then, of course, you can utilize, like we did before, any version of the browser that will support access to Defender ATP. Okay, now over the top of ATP, we have obviously Microsoft Intune that kind of bundles together. So Microsoft Intune helps protect devices and the corporate data utilizing things like security baselines that have been created, Azure AD conditional access, and then, of course, mobile threat defense. So there are a few things that it can do or that you need to do. The first one is to set rules on devices to allow access to a resource, manage the privacy and personal data, also manage personal device interaction and the networks they come from, define the authentication methods that you wish to utilize, manage any of the software guides that are available, and then, of course, use conditional access as you would. Now, some of the base ones that you will look at configuring, for example, device configuration. So Intune configuration policies will help you protect and configure devices to control the settings on the specific device. Obviously, you've got reset passcodes when users are locked out of their devices. So this allows you to remove a passcode or set a temporary one. Then, of course, retiring devices to be compliant and removing data. So this can be devices that are managed specifically in the mobile device management way. So that means that you've registered those devices, they've become managed devices at this point, and then you're able to manage all the restrictions on there. You've also got protect apps and data they use. This is one that will allow you to protect the application. So think of a bring your own device capability where I'm able to say Liam can use his personal device, but I want to make sure that all of the data is restricted. And so I can do that. And that will ensure that even if I try and copy Word documents, for example, from the OneDrive client to SharePoint or to something else, that I have a level of control over that and I can restrict that from happening. You've also got obviously adding an additional layer of protection to devices, which is available. So forcing specific controls over the top like multi-factor or application PIN controls. We can also obviously utilize Windows Hello. And then, of course, we can do activation lock. So we can require users to enter their Apple ID. We can obviously bypass some of that too, depending on how we configure the devices. So Microsoft Intune will provide a whole raft of security controls to protect device access into Microsoft 365. Now, one of those protection capabilities is called Application Guard. So Application Guard is designed to prevent old and newly emerging tasks. It uses unique hardware isolation to make this work. The goal is to make a current attack methods obsolete as it continues to learn. And then, of course, it's designed for Windows 10, and it's also designed for Microsoft Edge. So how does Application Guard work? Well, as an enterprise administrator, you'll define what is listed as trusted websites, cloud resources, and internal networks. Everything not on your list is then considered untrusted. So if the user goes to an untrusted site through either Microsoft Edge or Internet Explorer, Microsoft Edge will open the site in an isolated Hyper-V enabled container, which is separate from the host operating system. The container isolation means that if the untrusted site turns out to be malicious, the host PC is protected and the attacker can't gain access to the enterprise data. Now, the exploit guard contains 4 specific components. The first one is called Attack Service Reduction, or ASR. This is a set of controls that you can utilize to prevent malware from getting on the machine by blocking, for example, scripts and email-based types of attacks. You've got network protection, so utilizing endpoints. They're web-based threats by blocking outbound processes on the device that try to go to something else, and that utilizes some of the Windows Defender components. We have controlled folder access, protect sensitive data from ransomware by blocking untrusted processes from accessing folders. And then, of course, you have exploit protection, which also will use certain mitigations to ensure that system applications and running applications don't get exploited by certain types of malware, for example. Okay, so our next thing to look at is actually application management. So we've decided we've got ATP protecting bits and pieces. We have mobile device management specifically for devices that we protect using Intune. And now we're going to talk about what's called MAM. So this is Microsoft Intune Application Management. And so this allows management of client apps on a device. You protect the data within the apps. And of course, this is the BYOD piece. So we add, deploy, configure, protect, and then we can retire as needed. So what's the difference here? So Intune MAM, or Mobile Application Management, supports two configurations. One is called Intune MDM plus MAM. So this is where you as the IT administrators can manage the apps using MAM and app protection policies on devices that you actually manage anyway. So these are devices that you've registered and deployed and managed and protected using mobile device management. Then, of course, we have MAM with no device protection, which is the bring your own device capability. And what this allows me to do is to protect the apps that you choose, but not touch the phone itself. So if we were to look at what this kind of works out as, so if I'm doing apps without MAM, on a normal device, you have corporate and personal. Like my phone, for example, I have access to my corporate email, and then I also have access to Twitter, for example, which is personal. Now, of course, we have the device storage on the phone, and the problem is when apps are used without restrictions, company and personal data kind of gets intermingled with each other. So company data can end up in locations like the personal storage or transferred apps beyond what you would want them to do. So for example, I've got Facebook and Twitter here. And as I draw my arrows between them, you can see that when I have no MAM, this is what we have: unrestricted data movement between both corporate and personal apps and other storage locations. And so there's no protection here. So this is what we're trying to protect from. So what we can do is we can do data protection with MAM. So we're going to utilize mobile application protections. So what we have, same kind of layout again, our series of applications. And I've got my personal applications again. And then you can see that they can communicate from each other. And then, of course, we've got this communication that goes backwards and forwards between them. But what happens is when we utilize an app protection policy, it does this. So it will completely isolate. So, for example, it will block what's called data relocation. So policies like save as, cut, copy, and paste. And then, of course, access policy settings can require simple PIN access or block the managed apps from running on specific types of devices. Now, of course, if we go one step further and decide that we want to do data protection with MAM on a mobile device that's protected, oops, let me just go back here. There we go. I have my same idea again. So this is combining my MDM and MAM together. So the MDM solution adds the value by ensuring that the device is then enrolled into Azure AD and Intune. It can deploy the apps to the device, and then it will do device compliance and management. So if we go back to the way our data kind of structured, you can see we've got my breakdown here. I've got my Intune MAM policy over this side. And then on the bottom side, I have my MDM policies. So my MDM policy is restricting everything else, but my MAM policy is isolating the information at the top. The app protection policies bring the value by protecting the company data from leaking between devices. And of course, like we said, restricting save as, copy, clipboard, etc. Now, if we go the other route again, so this is your bring your own device capabilities. So same idea. We have corporate and personal with device. We have our applications. We have our personal applications. They're all kind of connected here. And we have my Intune MAM policies. This then gives you that level of protection. So what this does is there are some limitations in this. So for example, you as an organization, you can't deploy apps to the device. The end user has to do that. You can't provision certificate profiles on those devices, and you can't provision things like Wi-Fi and VPN settings on those devices, because all you care about at this point is the data protection of the content that's from your organization onto those mobile devices. Okay, so let's move on to our next skill, which is implement and manage information protection. So we've talked about authentication, we've talked about device management, conditional access, multi-factor, basically everything to get us to the door. And now we're going to talk about the data itself. So what are the data protection capabilities that are available? Well, for each of the 3 protection tiers, there are specific controls that can be utilized to protect the data. So for example, here we've got default file encryption, SharePoint permissions, external sharing policies, and device access policies. Now, from a sensitive data protection, we have tooling that can be utilized. So for the default file encryption, we have classification, labeling, and protection. For SharePoint permissions, we can use DLP. For OneDrive permissions, we also have 365 service. We have BitLocker, and then we have Windows information protection associated to it. Now, if we happen to be in a highly regulated or classified data, then of course we can bring your own key, use AIP, hold your own key, and Azure RMS. So when we're building data classification policies, you're going to kind of start on the left-hand side and then work your way up to the different capabilities that you wish to utilize. So first off, if we look at these 3 tiers again, so if we talk about device protection capabilities and identity, our base ones that spread across all the 3 different types. So for baseline protection, for sensitive protection, and classified protection, we have mobile app protection, so MAM. We have multi-factor, we have conditional access, and then identity protections. If we're looking at the higher end, where we have sensitive data and classified data, then we're going to utilize Intune management, cloud app security, and privileged identity management. From the baseline protection, we can then just use Intune management for all of those. Now, if we're looking at recommended policies for baseline, so this is our starting out point. If we draw this out here, we're going to utilize Azure Active Directory conditional access policies. We're going to use user risk policies and then Intune policies. We're going to require multi-factor authentication when sign-in risk is medium or high. We're going to require approved apps and then enforce mobile protection. We're going to block older clients that don't support modern auth. We'll require compliance PCs that are accessing the system. High-risk users need to change their password. Device compliance policies for each of the platforms, and then app protection policies as well. So this will be our baseline policy that we wish to utilize if we're starting out. Now, if you know that you have sensitive protection and sensitive data, then we can change this a little bit. We've still got require multi-factor. We've still got require approved, all the standard, but you'll notice that things have changed a little bit here. We're now blocking clients that support modern auth. We're requiring compliance PCs and mobile devices, and then we are enforcing password change no matter what. Now, if we move to a highly regulated, or you have super sensitive data, if we take this same approach, those 3 technology stacks, we're always going to require multi-factor now. There's no option. And we're going to continue to block and use the same capabilities. So it's important to understand that when you build the security policies that for your organization, you will start off with the baseline and work your way through to the most restrictive, unless you already know what content you have and that it is restrictive. So from a high-level policy implementation, you're first going to implement multi-factor authentication. That's step number 1. You'll then force multi-factor for device enrollment. Then enforce multi-factor for all admin accounts. Then configure single sign-on with Azure AD. Enroll devices for Intune for management. Then define device compliance policies configure those device policies, and then configure app policies for all the platforms. So from a high-level implementation perspective, you will perform each of these tasks. Now, of course, when you go to the exam and look at the scenarios, there will be some specific scenarios around this type of implementation. One of the next pieces that will be brought up is to do with customer lockbox. So what is customer lockbox? Well, it ensures that Microsoft don't have standing access to your content without approval. The customer lockbox brings you into an approved workflow where when a Microsoft support engineer needs access, you have to approve that. Also, the lockbox requires the engineer to request access from you. And more importantly, there are required licenses. So Microsoft 365 E5, Office 365 E5, and then any of the protection and compliance add-ons that are available. So how does this work as part of a workflow would go? So someone at the organization has an issue, let's say with Office 365. So after they've tried to troubleshoot it, then they open a support ticket with Microsoft. The Microsoft support engineer logs into the customer lockbox and then updates the ticket and then requests access for that. Then the Microsoft support manager approves the request. Then it comes to the user approval, which is required because it's been through the Microsoft approval, and then approved and access granted for the Microsoft engineer. So moving the customer lockbox capability to you means that you have access control over a Microsoft engineer being able to access information. Now, what this does as well is it triggers a creation of an audit record inside the Office 365 audit log so that you can then see and be able to, from an audit perspective, see that an engineer wanted access and that you approved the access, etc. Okay, our next thing, which kind of goes similar to this, is what's called Azure B2B. Now, the first bit we talked about was giving Microsoft access. But what about if it's not Microsoft you want to give access to, and this is external people? So this is Azure B2B. So Azure B2B is all about you securely sharing company applications and services with guests that don't exist in your organization. You can maintain control over your own corporate data by doing this. It uses a simple invitation and redemption process. So you send the invite, they have to redeem that. External or partner users can use their own credentials to access company resources if they have them. And then as a dev guy, you can use the Azure AD B2B APIs to kind of build your own process if you need to. Now, most scenarios require no license, so limited to simple access and collaboration. If you wish to utilize the paid features, such as conditional access, multi-factor provisioning and managing, then you will need to be licensed. Now, the licensing for this is really important to understand, and we'll talk about an example of that in a minute. But the guest licensing is automatically calculated on a 1:5 ratio. It's not possible to assign B2B guest user licenses directly to them. They don't exist. Now, what this looks like, so as an example, a scenario that you will see on the exam, something similar to this, you want to invite 100 guest users to your Azure AD apps or services and provide access management and provisioning. What you'll need at this point is for 50 of those guest users, you also want to require multi-factor and conditional access. So for those features, you'll need 10 Azure AD Premium P1 licenses. So think of the ratio 1:5. So I want 50 of them to have MFA and conditional access. So I just need 10 of those times 5 gives me 50. Then if you wish to use identity protection features with the guest users, you'll then need Azure AD P2 licenses at that same one. A second example of this, you want to invite 60 guest users who all require multi-factor auth. So in that instance, you'll need to have at least 12 Azure AD P1 licenses. So 12 times 5, that gives me 60. You have 10 employees already with Azure AD P1 licenses. Based on the 1:5 ratio, that would allow you to cover 50 of those guests. So you only have to purchase 2 additional Azure AD P1 licenses to cover the additional guests. So when you're looking at B2B licensing for external sharing capabilities, it does come down to the licensing that you have. And it's critical to go through and look at the licensing you've got to determine where you have the right licensing and then the 1:5 ratio that you can utilize. So how does B2B work? Well, a user is invited. So let's say I send the invitation to my user at the domain. The user then accepts that invitation. The account is selected, whether it's a Microsoft account, a work account, or an Azure Active Directory. Bear in mind, all three of those are supported. The difference between them, obviously, you've got Microsoft account, which is something like a Live ID, a work account, which is probably an Office 365 account. And then you also have an Azure Active Directory account, which actually could just be, I've got a tenant with an account, but not a 365 tenant. It could just be Azure AD for Azure. All of those then will go through some kind of account registration process to allow that account to be confirmed as a B2B user, and then that user can then access the application if needed. You can go into Azure Active Directory and you'll see the status of that account. So you can go in and click on the external user that's been added. So let's say somebody added that user via SharePoint or Teams. They will then list up as an external guest after they've gone through the account registration, and they'll be listed as an external user guest. You will also see the type of the guest that's listed in Azure AD, and so you can see where that's listed. Okay, so one of the big pieces of data protection is really around Azure Information Protection. So what is that? Well, it's a cloud-based solution that's based in Azure that actually helps you protect documents, and it bundles things like Azure Rights Management together. There are rules and conditions that are assigned to the policies. It integrates natively into the Office client, and there's a toolbar to add in too. And once protected, the content can be tracked and controlled. So how do labels apply the classification? Well, the Azure protection labels apply classification to the documents and the emails. Labels that can then be assigned that can include visual markings such as headers, footers, or even document watermarks. And then metadata is added to the files. And for example, if it's an email, it's added to the headers in clear text. So you can see that we assign the label. The labels are created with the specific security, and then all of that is then added to a document, which then becomes protected. So how is data protected with AIP? Well, it utilizes Azure Rights Management, which is like the old on-premises rights management capability, but it's built into the cloud. And the protection is applied by using the rights management capabilities, and it stays with the documents and the emails independently of whatever location it moves to. So we can apply encryption, permissions, and authorization, and then that's applied to the specific content. From a licensing perspective, you do need to license the information protection. It's included in the Microsoft 365 enterprise plans. There's also compliance plans, also 365 business plans, as well as inside the enterprise mobility and security plans. There is a free service, the self-service subscription for users in an organization. For example, if you've been sent a sensitive information that's been protected by AIP, then the end user can effectively utilize that. It doesn't have to be managed by IT. Then you have AIP for Office 365. So this is included in the E3 and above licenses. And then, of course, you've got the AIP Premium 1 license and the Premium 2, similar to the Azure AD ones, but the Premium 2 one is one that provides automatic labeling, classification, and, of course, has all the capabilities that you would expect. Okay, there's also an on-premises component that's built in to AIP for utilizing the cloud capabilities on-prem. So when you've configured labels, you can automatically apply them by utilizing the scanner. So the scanner can inspect any files that it can index by utilizing iFilters that are installed on the computer. Then to determine if the files need labeling, the scanner will then use the 365 built-in sensitivity information types, as well as pattern detection or regex patterns. And the scanner uses the Azure Information Protection Client, or the classic or the unified one, to classify and protect the contents. You can run the scanner in discovery mode only, where it will look through, for example, a file share or a SharePoint on-prem server and systematically crawl through the files looking for content that matches the labels that you defined. So this is a critical component that is available in AIP. It does have some very specific configuration in order for that to work. To install that one on premises, you first configure the scanner in the Azure portal. There's a profile that needs to be created inside Azure Information Protection, which is in the Azure portal. You then install the scanner itself. There's a download for that. Then you need to get an Azure AD token for the scanner. This is done utilizing PowerShell that you'll execute. It's quite extensive PowerShell to be able to get an authentication token back. Once that's done, you then run a discovery cycle and then view the reports to make sure that it was working as expected. And then you can then go back and modify the scanner to then apply any classifications and protection. So AIP is not just cloud. Obviously, definition, it's created in the cloud, but you can then utilize it on premises too. And as a side note, it's also bundled into things like the unified labeling. Unified labeling is the front end new modern version of AIP, which is available in the Microsoft 365 portal. Okay, our next security capability is data loss prevention. So what can you do with a DLP policy? Well, firstly, we can identify sensitive information across different locations. So we can, for example, find credit card numbers that have been stored in various locations. We can also prevent accidental sharing of sensitive information. So identify documents that contain health records that have been trying to be shared outside the organization, and then we can block those or block the emails, etc. Also, we have the ability to monitor and protect sensitive information in the desktop versions of the clients. So this is one thing that's a great feature, is that DLP, when connected to your Office clients, when you're signed in with the right account, can synchronize the DLP policies to the local Office applications. And then in real time, as people are creating documents, it will then go through and check in real time. So you can also help users to stay compliant. This is the key one for me. We can obviously provide messages to the users to say, hey, your content violated policy A, B, and C. We can also then view DLP reports that matches the content to help define a better security posture. So how does DLP work? Well, as people change or add documents in their sites, the SharePoint search engine will crawl the content so that you can search for it later. While this is happening, the content's scanned for sensitive information to check if it's been shared. Any sensitive information that is found is stored securely in the search index so that, for example, the compliance team can get access to that, but not end users. Each DLP policy that you've turned on runs asynchronously in the background and checking search frequently for any content that matches a policy. Finally, for any documents that conflict with the DLP policy, and they also become compliant with that policy. So, for example, if a person adds a credit card number to a document, it might cause the policy to block access to the document automatically. However, if a person comes back in and removes that sensitive information, then the blocking is automatically undone. So this is a constant process that runs. Creating the DLP policies is really straightforward and can be done inside the Microsoft 365 Admin Center, and that will allow you to protect the content. I often refer to this as this is your protective edge around like a fail safety net that would actually allow you to protect the content. Now, to go along with data loss prevention, as a perimeter kind of protection, we have cloud app security. Now, cloud app security is a bit of a big application. It's what's referred to as a CASB application, so a cloud app security broker. So it's going to broker everything in between the end user, the content, the applications, all the way to outside. So as users and devices connect to application using the credentials from the tenant, the information can be checked, validated, and blocked based on app connectors that might be defined, cloud discovery, and then proxy access and sessions. So you can use the cloud discovery to map and identify the cloud environment and the applications that are being used. You can then sanction and unsanction apps in the cloud as well. It's easy to deploy using the app connectors to take advantage of specific providers. So for example, if you had Dropbox that you were utilizing, there's an app connector for Dropbox. And so when users log into Dropbox with their accounts, the app connector can inspect that and give you information. You can also use conditional access app control policies that will give you real-time visibility and control over the activities and access within the applications. So an example here could be SharePoint Online. You could use conditional access app controls to restrict, for example, downloads of files, or at least inspect what's going on inside that application. Now, there are two different types of cloud app security. You've got MCAS, which is Microsoft Cloud App Security, and then you have Office 365 Cloud App Security. So the core capability here is cloud discovery, and for the MCAS, it will understand 16,000 plus cloud applications, risk assessments and analytics, and performs anomaly detection. Whereas the Office 365 version, that's kind of there out of the box, supports 750 cloud apps, which has similar functionality to Office 365. From an information protection capability, Microsoft Cloud App Security will do cross software as a service DLP, revoke permissions, policy enforcement, AIP enforcement, etc. Whereas the Office 365 version of that just uses the existing DLP that's available in E3 and above, and you can do some revocation of permissions and access. From a threat detection perspective, this is cross-application protection again for cloud app security, automatic and manual remediation, SIEM connection, security intelligence graph, and activity-based policies. And then cloud app security for Office 365 does a similar process to that one. Now, we can also compare Microsoft Cloud App Security versus Azure AD Premium as well. So Azure Active Directory Premium P1 includes Cloud App Discovery at no additional cost. So we don't need to use Cloud App Security to identify applications, because if we have the P1 license, that will do it. It's based on Cloud App Security Cloud Discovery capabilities that can provide deeper visibility into Cloud App usage. You will need to upgrade to Microsoft Cloud App Security if you want to utilize the full Cloud App Security broker capabilities. You need to be licensed to utilize Cloud App Security. So there's a standalone license, as well as the EMS licensing, as well as the Microsoft Security licensing, and the E5, A5 education and regular Office 365 licensing, as well as Azure AD Premium 1 does include Cloud App Security. Obviously, your account must be global administrator or a security admin to be able to make changes. And then, of course, use the required browser. And then you need to be able to access portal.cloudappsecurity.com, which will actually redirect to your domain.portal.cloudappsecurity.com. And then you can obviously go and configure as needed. Okay, so let's close out our last skill here for MS 500, which is manage governance and compliance features in Microsoft 365. Our first bucket here is security reporting. So the first thing we need to understand is what is Windows Analytics. So Windows Analytics is a suite of cloud services comprised of 3 different solutions. The first one is upgrade readiness, upgrade compliance, and then device health. I kind of put those the other way around. Device health is obviously about the device itself, for example, Windows 10 device. Upgrade compliance and readiness is all around the ability for your environment to, for example, take Windows 10 devices, autopilot, etc. The license requirements here, so beyond the cost of the Windows operating system, there's no additional cost for using Windows Analytics. Within Log Analytics, Windows Analytics is 0 rated. So this means it's excluded from the data limits and costs, regardless of the Azure Log Analytics pricing tier that you have chosen. So for example, upgrade readiness, there's no additional requirements except the Windows version is a minimum of Windows 7 Service Pack 1. Upgrade compliance is targeted to Windows 10 only. If you're utilizing device health, then you'll need Windows 10 licensing. So Windows 10 Enterprise or Education per device or software assurance, Windows 10 E2 or E3 per device, education licensing, the VDA for the virtual desktop, E3 or E5, and then Windows Server 2016 or later. Okay, Microsoft uses Windows diagnostics data to help define platforms and products. Diagnostic data is separate from functional data. There's the control. Microsoft offered the diagnostic data they share to provide easy-to-use management tools. The data that's utilized within Windows and Windows Server that's collected is helping Microsoft to make informed decisions on new features in the future. Microsoft encrypts the diagnostic data in transit using TLS 1.2 and additionally uses certificate pinning to secure that connection. From a legal perspective, Microsoft obviously support all of the local privacy laws that are available. And that goes across the board for Microsoft 365 and Office 365. And then, of course, there's no content-based targeting. So Microsoft takes steps to avoid and minimize the collection of customer content. So content that you may have, such as what's in the files, what's in the chats, what's in the emails. And if it is inadvertently kept, then it's confidential and not used for anything else. The Windows diagnostic data is a vital technical data from Windows devices. So if you are adding Windows 10 devices using Autopilot into Azure AD, for example, this will help in keeping Windows up to date, keep Windows secure, reliable, help Microsoft to improve Windows, and then, of course, allow personalized Windows engagement services if needed. Some example of the data would be the hardware being used, applications installed, usage details, and then reliability information on things such as device drivers. Now, to go along with the Windows data, we also have what's called Office Telemetry Dashboard. So the Office Telemetry Dashboard is an on-premises tool that will collect inventory, usage, and health data about the Office applications. This data is primarily designed to help you as the organization with application compatibility testing. The data is collected for the telemetry dashboard and stored in a SQL database that's controlled by you. This data is not collected and sent to Microsoft at all. And the data collected for the Office telemetry dashboard is not the same as Office diagnostic data. So what are the core components? Well, we have an Office telemetry log. This monitors for Office 2019 and Office 2016 versions of Word, Excel, PowerPoint, Outlook, etc. It's disabled by default. And the resulting data can be viewed in the local computer by looking at the telemetry log. The telemetry agent reports usage and inventory data for all of the Office clients. It reports application event data for those Office clients too. It can be deployed for Office 2003 upwards. It's natively built into 2019 down to 2013. You need to enable it using group policy or the registry. It runs as a scheduled task. It does require domain membership. Periodically uploads data to the shared location that you've defined and requires the latest version of the C runtime. You can enable and configure the agent for each client, part of the Office 16 ADMX and ADML group policy templates that are available. They are available at the Microsoft Download Center, and they get added inside the administrative templates for Microsoft Office 2016. The shared folder is the location where the data is stored. It must be on premises. It can be located on the same computer as other components, and it's configured when you install the processor piece. The processor itself is in charge of uploading the data to the shared folder of the database. It runs as a Windows service that you'll now see called Office Telemetry Processor. It's supported on Windows Server 2008 and higher. It can be run on Windows 7 with Service Pack 1 and higher. It can run on the same computer as other components, can be installed on multiple computers if you want to put it as a larger deployment, and does require domain membership. The database itself is obviously SQL Server 2005 minimum and upwards. It can be run on SQL Express if you're using a small environment, and it can be run on the same computer as other components. But this will help you as an organization to retrieve information about Office usage and to be able to make decisions about upgrades, etc. On top of that, you have access to the Intelligent Security Graph. The Microsoft Security API, or the graph, provides a unified interface for integrating to security applications and systems. The graph can be federated and bring queries to help onboard security providers and aggregate responses. The Security Graph API includes alerts and secure score information and is accessible from various coding languages also. So I could write a PowerShell connector to it, I could write Azure CLI, I could do C#, I could do something else. As part of the management and governance, obviously alert policies are critical here to being notified of when things have or haven't happened. So what is an alert policy? Well, an alert policy is generated when a user or an admin performs a specific activity. They are condition based, so you can define when that activity process alerts. They are available for organizations that utilize Microsoft 365, Office 365 Enterprise, E1, F1, G1, E3, G3, E5, G5 subscriptions. If you wish to utilize advanced functionality, then you're going to move to the higher licensing that is available, or add in advanced threat protection or advanced compliance add-on. From a policy configuration perspective, we first have the activity. This is the activity that the alert is tracking. So you create a policy to track an activity or multiple activities, for example, sharing a file with an external user or something else. We then have the condition. So for most activities, you define the additional condition that must be met. So for example, the IP address, it could be the location it's coming from, whether it's performed with a specific file name or something else. Then we obviously have the trigger. This is when the alert will be triggered. So you configure the setting that defines how often an activity can occur before an alert is triggered. Then, of course, we have the category it belongs to. So it can either be data governance, data loss prevention, mail flow, permissions, threat management, etc. We then obviously have severity. The severity is similar to the alert category. It's low, medium, high, or informational. And then our last one here is the notifications itself. So you can set a policy so that the email notifications are sent or not sent to a list of users when the alert is triggered. You can set a daily notification limit so that once the maximum number of notifications has been reached, no more notifications would be sent. And you can, of course, see all of these on the View Alerts page. Now, we also have logs available to help us in monitoring. So the first one is log analytics that is available, which is the preferred mechanism. So log analytics workspace within an Azure subscription is required first. So what that means is you have to go into the Azure tenant, make sure you have a pay-as-you-go subscription, and then enable log analytics workspace. Then connect to Azure Active Directory or whatever the service might be. Access granted at the top of the log analytics workspace, and then the relevant permissions are assigned within that chosen service. Now, the following roles in the Azure Active Directory have access to utilize the log analytics. So they are security admin, security reader, report reader, and then global admin. The Office 365 Security and Compliance Center is available for reporting and auditing. You can access it using protection.office.com is kind of the older way of doing it. We also then have the Microsoft 365 Security Center, which is security.microsoft.com. And then we have the Compliance Center, which is compliance.microsoft.com. Now, of course, these may change over time, but each of these are still available at the moment. Now, the available reports that we can see, the first one is alerts. This enables you to manage alerts, view security-related alerts, and manage advanced alerts using Office 365 Cloud App Security, for example. We then have permissions. So you can assign permissions to the report's capabilities, so compliance administrator, eDiscovery manager, etc. We then have threat management. So you can utilize the threat management piece where you're able to create those device policies. You can then view those policies that are available. We also have data governance, where data governance allows you to import email or share data from other applications, and then you can report on these capabilities. We have search and investigation, where you can obviously utilize the audit log, quarantine, eDiscovery, etc. We've then got reports that are just simple access reports for SharePoint Online, OneDrive, Exchange Online, and Azure AD. And then we also have service assurance ones. Now, this one's an interesting one. It's not something that you would necessarily have to utilize, but these ones provide information about how Microsoft themselves maintain security, privacy, and compliance. So you can access the third-party ISO, SOC, and other audit reports, as well as the controls and any third-party verified auditor capabilities that were created. Now, one of the key things that we can do is search the audit log, and the process for this is to first run an audit log search. Then we view the search results in the audit log search. Then we can filter the search results, and we can then export those search results to a specific file. And of course, there are hundreds and hundreds of different types of capabilities that we can search for and activities that we can search for, as well as filtering by date range and then specific users or different types of files or locations. So what are the common scenarios that we would use the audit log for? Well, maybe finding the IP address of a computer that was used to access a compromised account, determine if anybody's set up email forwarding for mailboxes or mailbox, determine if a user deleted email items, determine if a user created an inbox rule, investigate why there was a successful logon by a user outside the organization, and then identify resources shared with external users. The audit log is literally that. It's an audit log of all activities and actions, whether user or admin, that have taken place, and you can obviously access those at any point. Okay, so now let's move into governance and compliance. So what can retention policies do? Well, a retention policy can help you achieve all of these two goals. So the first goal is retain. So retaining content so it can't be permanently deleted before the end of that retention period. Delete, so we can delete permanently at the end of a retention period. With a retention policy, you can decide proactively whether to retain the content, delete the content, or both, or retain and then delete the content. You can assign a single policy to an entire organization or specific locations or users. You can also apply a policy to all content or content meeting certain conditions such as specific keywords or sensitive information. Now, to understand how different retention policies are applied to content, you have to keep in mind these key principles. Retention wins over deletion. So suppose that you have a retention policy says to delete Exchange email after 3 years, but another retention policy says to retain Exchange email for 5 years and then delete it. Any content that reaches 3 years old will be deleted and hidden from the user's view, but still retained in the recoverable items folder until the content reaches 5 years, when it's permanently deleted. The longest retention period will always win. If content is subject to multiple policies that retain content, it will be retained until the end of the longest retention period. Explicit inclusion wins over implicit inclusion. So if a label with retention settings is manually assigned to a user to an item such as Exchange email or a OneDrive document, that label takes precedence over both a policy assigned at the site or mailbox level and a default label assigned by the document library. So if the explicit label says to retain for 10 years, but the policy assigned to the site says to retain for 5 years, the label takes precedence. If a retention policy includes a specific location, such as the user's mailbox or OneDrive for business account, that policy takes precedence over another policy applied to it. The shortest deletion period wins. Similarly, if content is subject to multiple policies that delete content with no retention, it will be deleted at the end of the shortest retention period. Understand that principles of retention work as a tie-breaking flow from top to bottom. If the rules applied by all policies or labels are the same at one level, the flow will move down to the next level to determine precedence for which the rule is applied. So how does retention apply for SharePoint Online and OneDrive? So if the content is not modified or deleted during the retention period, it's moved to the first stage recycle bin at the end of the retention period. If a user then deletes the content, from there, it empties the recycle bin, which is known as purging, and the document is then removed to the second stage. There's a 93-day retention period that spans both the first and second stage recycle bin. At the end of the 93 days, the document is permanently deleted from wherever it resides in either the first or the second stage recycle bin. If the content is modified or deleted during the retention period, a copy of that content is stored in the preservation hold library. There, a timer job will run periodically and identify items whose retention period has expired and then moved to the second stage recycle bin. And then it goes through that 93-day time again. So how do retention policies work for Exchange? So the same kind of process here. If an item is modified or deleted or permanently deleted by the user, then the item is moved to the recoverable items folder. And then there is a process that will run to permanently delete it within 14 days of the end of the retention period. If the item is not modified or deleted during that retention period, the same process runs on all the folders, and then it will be governed by that 14-day or 30-day. So how do retention policies work for Microsoft Teams? Well, if a chat or channel message is modified or deleted by the user during the retention period, the message is moved to the substrate holds folder, where it's a hidden folder, and is stored until the retention period expires. Messages are permanently deleted on the day the retention period expires. If a chat or channel message isn't deleted during the retention period, the message is moved to the substrate folder within 1 day after that retention period expires. The message is then permanently deleted 1 day after it's moved in that folder. Now we have what's called the Label Activity Explorer, where we can view label activities for documents. So after you recreate those labels, for example, for retention, you'll want to verify what they're being applied to, and you can utilize this for that. You can also use the Label Analytics view. So after you recreate the labels, you want to see how they're being used. With Label Analytics in the Compliance Center, you can see which labels are being used the most and where they're being applied. And then, of course, we have the data governance reports that allows you to verify that they're being applied to content as you intended. Now, of course, if we're utilizing label usage within the label analytics, you'll see the total number of retention labels and sensitivity labels applied to content, the top labels and the count of how many times they've been applied, as well as locations where they've been applied, and the count for how many files and folders had their retention label changed or removed. Now, to help us in doing this, we can also utilize content search. So content search is a tool within the eDiscovery tool that allows you to search for content. You can search within Exchange Online, SharePoint Online, OneDrive for Business, Skype for Business, Microsoft Teams, and Office 365. This is a core piece of eDiscovery. So after you run a content search, the number of content locations and estimated number of search results are displayed in the search statistics. You can then view those and then export the data to the local computer if needed. If you wish to utilize the advanced eDiscovery components that come after doing a content search, then you'll need to have an E5 license, or at least have the advanced compliance add-on license. You'll need to be an administrator or compliance officer assigned to that. You'll also need to be a member of the eDiscovery manager role within the Security Compliance Center, and this will be questioned on the exam. From a regulatory compliance, we can utilize the compliance score. The Microsoft compliance score helps you to simplify the way to manage compliance and reduce risks through a kind of list of things that we found that need to be changed. You also have GDPR compliance, information protection for GDPR compliance, ISO compliance, and then NIST compliance capabilities. Okay, so all in all, that's all 4 areas and topics covered for the exam. In all of the topics that are there, those are areas that will be brought up in the exam itself. We hope that the Exam Cram has helped you understand the focus for MS500. Don't forget that you have access to lots of other Skill Me Up live resources, as well as go through this again, and also the training that was built for this. I'm the author for the MS500 course itself, so feel free to go through that one. We can also help you order and manage certification vouchers for yourself or for teams, making it easy to purchase vouchers in bulk and distribute them as needed. So in summary, we can't stress enough how excited we were to have you working with us. We hope the presentation provided you with enough background for you to understand the exam and also how we approach course design, obviously at Opportunity here. If you have any questions about anything that's something that isn't here or something you would like to learn, then please reach out to your project manager or CSA that's available, because we're always looking for ways to improve. And of course, we don't know where the holes are if you don't speak up. But in summary, we covered the exam review. We looked at the 4 key skill areas and the domains, such as implement and manage identity and access, implement and manage threat protection, implement and manage information protection, and then managing governance and compliance features in Microsoft 365. As I've said before, it isn't the easiest exam, so I wish you good luck in taking the exam, and feel free to watch this again, as well as also go through and take the MS500 course that's available on Skill Me Up. So thank you for listening today, and I hope you enjoy the rest of your day. This was the MS500 Exam Cram, and my name was Liam Cleary, and I hope you enjoy the rest of your day.